Hey, here's your Similarity Foldable. So add to your table of contents, if you didn't already, line E, triangle similarity. And that's going on page 56. Okay, so let's go ahead and look at these because there are actually three different ways to prove that triangles are similar. Now we know when something is similar that it's going to have all congruent angles that are corresponding to each other, and then the sides are going to be proportional, which means you can make fractions because they get bigger or smaller by the scale factor. So there are three ways to do that. Now, obviously, just like when we prove triangles congruent, we can prove them similar by using some shortcuts. Now, there's only three different shortcuts we can use. There's angle, angle, and that means if two angles of one of the triangles are congruent to two angles of the other triangle. So if we have two angles, and they have to be congruent. So make sure you realize that is congruent. Then we have similar triangles. The next way is if you have two triangles, if a pair of corresponding angles is congruent. So we have one angle, like this guy, congruent to this guy. And then we have sides that are going to be proportional. So, for example, this side right here, you could put over this side, right, as a fraction. And then this side over this side. Now you see how side, angle, side, do you notice how both of these sides have to be touching the angle? So both touching the angle, just like we did when we had congruent. And then the third one is side, side, side similarity. Now this is not congruent. This is proportional. So both of these are proportional. So for that means you can make three fractions, like this over that equals that over that equals that over that. So you can make three fractions. This one, I know we marked it on here. I should probably mark it on the writing too. So we have a pair of corresponding, we have the angle congruent, but then the sides on either side of it, the sides are going to be proportional. Okay, so let's see what that looks like. When you open it up, the examples are going to be right next to it. So we have two examples for the AA similarity. So AA similarity means I have two pairs of congruent angles. Now we know a lot of stuff in this picture. So the first thing we have here, we have some parallel lines, right? When we have parallel lines, we can check for the Z. Remember, if we have parallel lines, look for that Z, because then we have alternate interior angles, right? Only if we have parallel lines, and we do because this says parallel to that. So that means we can look for the Z. So get a colored pencil. We can make a Z that looks like this. Boom. Remember, at the top and the bottom of the Z are the parallel lines. Then that means we have alternate interior angles. So that means this angle is congruent to that angle. Those are in the cracks of the Z. Now, we can do a Z the other way also and get another pair. Let's mark these two as alternate interior, because remember, if we label something, we need a reason. Alternate interior angles congruent, only with parallel lines. We also have some vertical angles in the center here. So we can use these vertical, or I could have done a backwards Z and gotten another one. But remember, all we need are two angles. So that means that these two are similar by angle, angle. So these two have angle, angle similarity. And remember, you have to name them the same way. So I'm just going to randomly name this one over here. So I will call this one triangle JHK. That is this guy over on this side. Now remember, I have to match all the parts on the other one. The similarity sim is just the squiggly triangle. I'm going to do this guy over here. So What matches the J? So the J had this arc, so that is this F. So I have to start with F, right? The H came next. The H is the angle with the double arcs. Double arcs right here. So that's another H, angle H. And the last angle was the one with nothing, and that's the G. Okay, and the reason for these two was vertical angles congruent. Okay, let's go ahead and look at this picture here. Now, this one has the triangle kind of inside the other triangle. So it looks like it's being stretched from this X point and getting longer this way and longer this way. So I'm going to have my two triangles. One of them is going to be this green one. And I'll make the other one be this pink one. Green one and the pink one. Okay, so I clearly have one pair of angles that are given. So this one is congruent to this one, and that's given, right? I need another pair of angles. I don't have any side measures, so, but this obviously is clearly the AA flap. Now, we don't know about any parallel lines in this picture. Now, if they told us that these two were a dilation, then we would know these two are parallel, but they don't actually have any words here and they don't have any markings, so we cannot assume. Okay, so far we have an A, right? This A right here that's given. But if you look at the top here, look at this angle. Let's talk about this angle up here. Do you see that angle up there? Do you see how that angle is a part of the green triangle, and he's also a part of the pink triangle. So this angle up here, this is a reflexive property because something is always congruent to itself, right? So the reflexive property. So we actually have another A right here. And remember, we are given an A right here. So once again, we do have an AA similarity for this guy. These two triangles are similar. By angle similarity. And remember, we just have to name them the correct way. So I'm going to name the top green guy. I'll just rando call him XWV. He is similar to the pink guy. Remember, you got to match up. Still at the top is going to be triangle X. And then coming down, Z over to Y. So we do have some pairs of similar. Okay, next one. Side angle side similarity. And so remember, if we have two triangles where we have this, remember the inside one has to be congruent, but these two have to be proportional, which means they have to be equal fractions. Okay, so we do have the angle. So boom, boom. It says 120 and 120. So we do have the two angles congruent. So that looks great. Now we just need to see if these are going to be this proportional, which means are they going to have equal fractions? So it doesn't matter what you pair up as long as you're consistent. So this side here and this side here. So this is a 9, even though it looks weird. So let's see. If I do the small one over the big one, that's a 6 over 9. Now we don't know which is new and which is old because we just have two shapes. So I'm just going to do small over big. It doesn't matter as long as you stay consistent. Then our next pair, we got this 4 and the 6 are paired up. Those are also going to be corresponding. Now remember, we want to do small triangle over big triangle. So small triangle over big triangle is 4 over 6. Now we just need to see if these are equivalent to each other. You probably learned how to crisscross. You could crisscross multiply and see if they're equal, or you could put these into your calculator. So I could just put in 6 divided by 9 in my calculator, and I get 0.6 repeating. So this is 0.6 repeating. I put 4 over 6 in my calculator. 4 divided by 6 I once again get 0.6 repeating. Or I could have crisscrossed. You see how that is a 36, and that 9 times 4 is also 36. So these are proportional. So that means that these two sides, and we just have to check to see if are our two sides touching the angle. So here was the angle, right? This is one of the sides, and this is one of the sides. Are both of these sides, pink sides, touching that angle? They are. So we do have side, angle, side. Similarity. I use the little symbol for the squiggly. So that means I have triangle. I'm just going to name this guy any way I want. I'll do M, N, L. M, N, L is similar to triangle. I got to do it the same way. So where am I going to start in this guy? Over here at this P, and then to the R, and then to the L. So these, oh, that's not an L, that's a Q up there. Q. Okay, let's look at this guy over here. Notice he looks like the last one above, the triangle inside the triangle. So right off the bat, we know we're going to have this angle on the top, the reflexive property. That's the reflexive property. So our two triangles, make sure you color them different colors. We have this pink one, and then we have this big yellow one. Okay, so I do have an A, so I do have congruent angles in the top. Now I just need to see if the sides are going to be proportional. Now remember, you got to do, we could do the same way we did on this one. See how we did little triangle over big triangle, little triangle over big triangle, and see if they were equal. So let's talk about the little triangle. The little triangle is pink right here. The little triangle side is 6. And what does he match? The big triangle side? Be careful though. What is the size of the big triangle? That's a 9 because it's a 6 and a 3. So that's a, okay, let's see if it matches the other side. The other side, the little triangle is 10. And then the big triangle is 10 plus 5. That's 15 because this whole side is 15. So we just need to see if these are equal to each other. So if I did 6 divided by 9 and then 10 divided by 15, would I get the same thing? So I have 6 divided by 9. Hello, it's the exact same thing as the last problem. And then 10 divided by 15. That's just coincidence, 0.6. And so, yeah, these are beautiful. So we do also have side, angle, side. Remember, check to see if both of the sides are coming to this angle. So this side is coming up and touching it, and that side is coming up and touching it. So they're both touching it. So we do have side, angle, side similarity. And since I made such a mess of all of these things, you can go ahead and make your similarity statements. Make sure you name them in the right way. So maybe you did L, K, M. L, K, M is going to be similar to the big triangle, same order, L, E, can't read what that is down here, L, E, J, L, E, J. And then the last one, okay. So we have triangle, side, side, side. These are examples of side, 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 where you don't need any angle measures congruent. All you got to do is pair up all 3 pairs. So we have to make 3 fractions and see if they work out fine. So here's what I do. I take a look at this triangle and I put them in order. I always do the smallest one and then the medium one and then the large one. So the smallest side on this one, I'm going to put small triangle over big triangle. So I'm going to do this triangle, triangle A. So I'm going to do triangle A over triangle B every single time. And that way I won't get anything out of order. So I'm just going to go in order. I'm going to pick the smallest size. So 8, 16, or 12. So that's going to be an 8, right? Now I got to go to the other triangle. Triangle B is going to go on the bottom. So look at all these guys. Which one's the smallest? The 12 is the smallest. So he pairs up with the 8. Okay, the next piece. I'm going to pick the medium side. So if I look at this, I already did the 8, right? And I already did the 12. Those guys are out. So who's the next side, biggest one? That's 12. And remember, triangle A is going on the top. Who's he going to be paired up? Who's the medium side on here? That's the 18, right? And then we do the largest side is the 16. The largest side on this one is the 24. So remember, you got to check all these. And are all of these equal? Are they? Put them in your calculator and check out. So 8 divided by 12. I got, oh my gosh, I'm getting the same answer for all these. 0.6. Repeated. 12 divided by 18 is also 0.6 repeating. And 16 divided by 4 is also 0.6 repeating. And this is just coincidence. These are all coming out to be 0.6. I hope this last one does not do that. That'll be weird. Okay, so these two triangles are congruent. I'm sorry, are similar by side, side, side similarity. When you name the triangles, remember to try to go in some kind of order. So I'll just start with the V, and then I'll come down the shortest side to the W, and then I'll go down the medium side to the U. And I just got to do the same thing on the other triangle. Remember, I went down the shortest side. So I started with the G. I went down the shortest side, which was the 12, to my H, and then the medium side to my J. And then those should be matched up nice and pretty. All right, this one. Here's another one of these pictures that pops up all the time. Kind of like just like the one up top. When you have these triangles inside of triangles, you usually end up with that reflexive angle at the top. This is something here. This actually is a right triangle. This whole big one's a right angle up top too. So it's kind of like a right triangle with the altitude, the height drawn in it. And what happens is all three triangles inside this end up being congruent. I'm sorry, similar. Okay, so let's go. Let's talk about similar triangles. There's actually 3 similar triangles. Let's just do which 2 triangles do you want to do? Do you want to do this yellow one? And then you want to do this big giant one? Let's see if those 2 are similar. The yellow one, because we have a third triangle here. Actually, it's going to turn out that they're all going to be similar, but let's just pair up some sides so we can see what it looks like. Let's just do the yellow guy and the pink guy and ignore this white one right now. Okay, so I'm going to, let's talk about the yellow guy. Let's put the yellow on the top. So I always like to make a code. Like this one I did A over B every single time, and that way I didn't get anything upside down. I'm going to do yellow over pink. Oopsie. Yellow over pink. Okay, so yellow over pink. Okay, so I'm just like to stay. I like to start with the smallest side. I'm just stay consistent. So let's look at the yellow guy. What is the smallest side on the yellow guy? I've got the 9, the 6.75, and that. So the smallest side is 6.75. Okay, now I'm going to look at the pink one. What's the smallest side on the pink one? I got the 11. I've got the 15. What's this bottom one? I've got 12 plus 6.75. So altogether on the bottom, that is at 18.75. You got to add those up, right? So what's my smallest one in the pink triangle? That's going to be the 11.25, right? Okay, let's do the next side, the medium side. Okay, the medium side of the yellow, because yellow's on top. Medium side. So I already did the 6. What's the next one? 9 would be the medium side, right? Now I have to look at the pink triangle. What's the medium side on the pink triangle? Well, I did the bottom. That was the longest side. I've got this 15 or this 11.25. So the 15 is going to be my medium. And then my longest side on my yellow triangle is going to be 11.25. And that's going to match up my longest side on this one, which is my 18.75. So I just need to put all those in my calculator. 6.75 divided by 11.25. Let's see, 6.75 divided by 11.25. I got 0.6, not repeating. Okay, so I got a little bit of a different answer this time. 9 divided by 15 is 0.6. And then 11.25 divided by 18.75 is 0.6. So, yay, I do have side, side, side similarity. And I'm pretty much out of room here to do my similarity statement. Now, remember, you could do this one more time. You could take this green triangle and mash it up. Do like the green over the pink or the green over the yellow and see if it's going to be also going to be similar. And remember, this gets glued in your notebook on page 56.